We're recording now, so over to you, Pat.
Thanks very much, Rob. Hello, everybody. Just going to get this moving now. Sorry. There we are. Yeah, hi, my name is Patrick Boyle. I'm the Senior Technical Officer in the School of Psychology at DCU. My own research interested in, on the screen, VR. I have a particular interest in education, and in this particular project, it was about looking at microteaching. And the project started off, this particular element of the research stems from another project called AI for Social Good, which was in DCU. And it was a project that was spread across a number of schools with researchers throughout the university. So I'm going to talk then about our particular element of the project, which was the micro-teaching element. Micro-teaching is like a teacher training technique that provides teachers opportunities to build and improve their teaching skills. It resides between that area of the theoretical knowledge that teachers need to know and the practical side for teaching in the classroom. So we were looking at how can we actually help to bridge that gap, because sometimes pre-service teachers feel that they don't get enough time to actually practice their teaching methods and their skills. So this was a way to try to actually see how we could build and generate something that was actually going to be useful. So the system we created was called MyTeach VR, and it's quite as simple. It stands for micro teaching in virtual reality. And the system gives trainee teachers the opportunity to stand in a full life science classroom. So it's like situated learning for them. It allows the teachers then to practice the fundamental skills of teaching that they need as a teacher, and it provides opportunities for them to reflect on their own teaching practice afterwards. But it also provides a safe space for the students, especially those students who may not have actually taught in the classroom before, and especially new teachers and teachers that are coming from secondary schools into tertiary education who may never have actually stood in front of a class and spoke out loud. So that was part of the goal. So the functionality of the system allows the voice to be recorded, hand and head movements, and records the movements as they move around the classroom. So you want to record the voice because obviously when teachers are speaking, they can practice their voice modulation. They can practice how to their various different skills of the topic they're talking about. It records the hand and head movements, look at gestures, etc. And then we wanted to see how they could navigate around the actual classroom as well. So we recorded those functions. The system also allows them to use a PowerPoint. So the students, before they come to use it, they generate their own PowerPoint. It gets uploaded into the VR headset, and they can use that within the class as a guide. Because in a lot of instances, when they're doing micro-teaching, traditional micro-teaching, they may not use a PowerPoint because they generally have notes in their hand. But obviously within VR, it's much more difficult to do that. So one of the options we looked at was to try and create a sort of a notepad, but we opted then to go for the PowerPoint because it seemed a bit more natural when we spoke to some people. There's a whiteboard, and it also has a function that allows them to actually hand out their some class materials. And then the record option is useful because reflection is a big part of micro teaching and teacher training. So the record function allows them to actually reflect back on their own session after they've actually completed their teaching session within the virtual environment. So how do we actually create this? So we did a five sort of section cycle for creating the actual system itself. We looked at I'll go through these briefly. We had a design stage, we had an alpha stage, and where we designed and tested it. We went then to a beta version. Again, we've done some more to redesign and testing. Then we went to a live prototype, and we went then to collect data. And I'll talk about each of those now in turn. So the requirements planning, initially we had to sit down and actually see what did we want to actually use or collect in virtual reality, and also what was possible to collect in virtual reality. So we mapped out some of those skills that we could enact in VR, so movement, voice, communication skills, etc. And and then obviously the data we're collecting is biological data because we are collecting actual voice. We consider the data storage because the headsets are the Oculus 2 headsets, and we transferred the data from those up to a server that we have, a secure server in DCU. Again, we looked at the functional requirements. what could or could not be built in the system. And then with the development platform we used was Unity, and we then had to build a server for it to actually account for all of those interactions that we have between the headsets and the software itself. So this is a schematic of roughly what we had. So we can, if we had, luckily we had a computer that allowed us to actually upload the PowerPoints into the up onto our server, and then from there the PowerPoint was available to the individual students. So we could have multiple students using multiple headsets simultaneously, and they were all connected separately wirelessly to the actual server. So each individual's recording as well was mapped to a session ID. Within there, that's how we kept that security for each of the individuals. And then as part of the design, we needed to sit back and look at classroom layouts. And these are two rudimentary ones that we've done initially. And the one on the left-hand side, teachers that are on the audience today will probably be horrified that these lines of students in the classroom. But we created that traditional one, and we created about 5 other options. We also had an option as well that they could actually use and create their own classroom layout. So it was a free sort of standing classroom. This is a screenshot of the initial alpha testing that we've done. We've done a very rudimentary options within there just to actually test the size of the room, test the functionality, get a scale, and look at the artifact positions that we needed. And then rather than actually using the higher end graphics, that was easier just to keep the system flowing. We then moved on to our beta version, and in that one we changed the actual, you can see the little avatars down on the bottom. They change color depending on the state that they're in, asking a question or doing something else within the classroom. On the top left-hand side, we had a rudimentary PowerPoint board and a whiteboard. There was very little change in the actual aesthetics of the room there. A lot of it was really due to functionality that we built into the system in the background. And from there, we then moved into a live version, and we selected these particular avatars because we asked a number of people what type of avatars they'd like. And it was actually, we found it a bit restrictive in trying to get avatars that would be suitable to everybody. These ones were sort of, to a certain extent, were age neutral when we started to look at them. They also had a good diverse mix of males, females, and skin tones, which we wished to actually which we really wanted to incorporate into the system. So what were the challenges that we had? Some of the challenges we had were meta issues in trying to sort out and set up the headsets. There was a few problems in relation to those. Software deployment and development delays. Some of the software took a long time to develop some of the aspects of the software. And then we had run into some server problems, which was a challenge. And then in the field itself, when we started the testing, we had issues then around Wi-Fi connection issues. We had issues then because we had a full-size virtual room. We needed to have a room that was at least 6 meters by 6 meters, so people could actually walk around within the actual room. So to clear out those rooms and have a dedicated room, again, was another bit of a challenge each time we went to use it. And then hygiene was another issue in relation to cleaning the headsets after people used them. So we then continued on to do some testing with students and with lecturers, and in general, the participants did not see that the virtual reality system as a replacement for traditional micro-teaching practice. However, they did indicate that it could be used in conjunction with traditional delivery methods. And they had a number of different reasons for that. Some of the reasons were that they felt that even though they liked virtual reality, and in some cases they felt that it was safer for them to do in virtual reality, they also felt that lack of human interaction was a problem, and that they would have to face into facing humans at some point in their teaching career. So they also indicated as well that the environment was realistic, with some caveats like commenting on the limited interaction with the avatars. So the avatars had limited interactions in the initial prototype version. Again, the participants felt that the system had potential to improve their confidence in speaking, their confidence in moving around the classroom, the presentation skills, and their skills for public speaking. was another area that they felt would be good for them. Um, they indicated that they would be willing to use the system that was available as an independent learning tool for practice themselves at home. So, for example, some of the students said that when they go to practice microteaching, they generally do it at home by speaking at a mirror or talking to themselves in a room on their own. This way, if they had a VR headset, it would be actually better in as far as, again, it would bring into that situated learning for them, that they're in a situation that looks similar to what they're going to actually face when they go to teach in the real world. Again, some of the participants saw potential to be able to use the system beyond just practice. They could practice for future sessions that they might want to do. So, for example, we had one student who was doing live micro teaching, but he brought his PowerPoint into the system, into those sessions, the testing sessions, and practice it in there before he went to do the actual traditional live micro teaching session. Again, the participants felt that the system was a safe environment to learn in. They felt that they didn't have to feel judged by other people looking at them because they were there on their own. And they just felt more comfortable, especially students that were in the early stages of teaching. And then, as I said earlier on at the beginning of the presentation, a reflection is a huge part of initial teacher education. So participants found that the record function benefited them, improved their practice, enable the students to watch and listen to their own session. So after the session, the students can go back in, they can actually replay the session and they can hear their voice. They can also see an avatar that represents themselves moving around the actual virtual environment. And some students found that actually interesting because they could actually move to different parts of the room while the session was playing. They could still move around the actual virtual environment and look at themselves in different angles. Again, participants indicated that you can analyze their own performance and make changes to their own teaching practice and help for improvements. And they also mentioned that technical support was what was needed in as far as that if they wouldn't particularly want to be using a VR, if they couldn't have the support, if they had a problem with it, rather than wasting their time, they felt that support was really important. Otherwise, that they probably wouldn't opt to use it if it was left as an independent tool. And that's what's the impact of what we've done, what we found out. In general, based on the feedback from both the students and the lecturer, it appears that the system itself has a place in microteaching education. As I said earlier on, it's not, they don't feel it's a replacement for microteaching, but they feel that it could be something that could be incorporated in as an extra add-on that students could use and in a different way and probably learn in a different way to what they do when they're actually in a traditional class. They feel that it can enhance their skills development. Again, for independent learning, they can take it themselves and either do it in college or take it at home. They spoke about having it as a library option that could be borrowed from the library and hopefully would improve student outcomes. And I suppose then we need to have some sort of modifications to current microteaching aspects if it is to be brought into the system. And I think I'm going to finish there by just acknowledging other people that were involved, which is Dr. Sabrina Fitzsimons, Peter Tiernan, and the AI Social Good project team.
To start the recording, and I'll hand over to you, Matthias.
Yeah, thank you. Thank you very much for inviting me, for introducing me. Today I want to talk about from consuming to co-creating 360-degree media and authoring tools and participatory learning and inquiry-based learning. But first, let me start at the beginning. Why 360-degree media and education? In the last years, there were significant investments in digital equipment. Here in Germany, at last, there is a lot of money put into schools and teacher training centers and municipal media centers. And it started with the pandemic, but it did not stop there. So our government is pretty active at the moment. So our university followed suit in 2021 and established a media lab for digital media and teacher training at the Teacher Training Center, which I had the opportunity to build up from the beginning. And we bought a lot of equipment. We developed a lot of concepts. We got in contact with schools, with teacher training centers, with school authorities, with trainee teachers, and of course with our students. And yeah, we found out there are some major challenges in the field of digital media we have to overcome to really productively use it in practice. And one of the main challenges is that teachers want to be able to produce content, not just consume it. And this is, as we will see, especially true for virtual reality. Often there are finances for initial equipment. So you could buy VR headsets or whatever, iPads, and there's little room for content, for software, for even subscriptions, because that's simply not feasible for schools here in the area. Professional, especially open source tools, have pretty high barriers to entry. This is what triggered us to go on and start the approach I'm presenting here today. So VR technology, as we all know, is pretty new in the education area, at least at the broad scale. The market is still somehow volatile. Models manufacturers come and go, but there's some consolidation we see. Different approaches also differ in school suitability. There are privacy issues to be considered if you use Meta headsets, for example, or other aspects we have to look into. But still, the trend is positive. And if we talk about immersive media in general, we don't just have to talk about VR and AR, but also, for example, about tablets, which are available, at least here, at large scale in schools. Every school has at least one class set of iPads. Some even have mandatory iPads for their pupils. And yeah, students can actually work with that. School children know, at least since Pokemon Go, there are AR, XR capabilities in there, which you could use for this magic window effect, while most teachers still regard tablets as mere PDF viewers. So it's now widely used in school, but we have no or little opportunities for teachers to create immersive content there. And how is it important? I mentioned our government took some money into their hands, and unfortunately, the press release was only available in German. But you see here, with the beginning of this year, our state government bought 3,000 VR headsets to make them available for schools. So the hardware is there, but what is with the software? So we see a content gap here. There is content available, of course. Often it's commercial content, which brings the challenge that you have to pay for it, and there's little money for payment there. Or you have to use open tools, free tools. But if you ever try to tell a teacher, yeah, use Blender and Unity, learn it to create your own content, teachers don't have time for that. Most don't even have the expertise. There are a few drag and drop tools available, but they are either expensive or not made for education. Most free services give up at some point. We're looking at Mozilla Hubs, for example, which canceled their free service last year, I think. So 360-degree images or media might potentially bridge that gap. Cameras are getting affordable. There are 360-degree images like the Insta shown in the corner, which are cheaper than the average new GoPro model. And the amount of freely available media on the internet is slowly increasing as well. There's open educational resources, stock photos, which could be used at least of some popular places and historical monuments and so on. Still, there's a gap also in this sector. Most all-in-one tools are made for the real estate market and therefore pretty expensive. The few free tools we found in our research have significant limitations. Like Marcipano does not really understand the principles of open educational resources, and H5P does not support immersive VR and VR headsets. So in our approach, we started in 2022 to close that gap with a proof of concept. We derived requirements from our research. So we said focus on 360-degree media because it's the lowest threshold available. Design of interactive content has to be possible. It has to be web-based because in most schools you can't just install software, and it should be low threshold. There should be a broad range of target devices compatible, so it should be usable in PC and tablet, smartphones, and of course VR headsets. The deployment should be as easy as possible, either on premise if you have privacy concerns, for example, or as a service, for example, for a state government. And it all should be open as possible, so it should be open educational resources aware, so that teachers can create but also export, import, share, and modify content. Our proof of concept looked pretty promising. A lot happened since then. But before I go into that, a short excursus on 360-degree media. Rob introduced me to present something on 360-degree video, which is also possible with our approach, but not our main focus. And I can tell you why. Of course, it offers high fidelity, high immersion. You can put more information in a video than in a picture. But there's a serious problem if you put it in VR, for example, because you have always that limited field of view. And if something goes on in time, you might miss information. You have to do a lot of post-processing, meaning signaling, like turn around, the interesting stuff is happening behind you. So you increase the cognitive load a lot. And this is why we opt usually for panoramic stills and say we might have a lower fidelity, we might have a lower agency, and it conveys less information, but it accommodates different learning speeds and learning strategies. We need less signaling and it's easier to place hotspots. Apart from that, if you offer it as a service like we do in our research instance, smallest file size plays a role in there as well. But before I go into details about our software, I will do a short demo. So we can create a new tour here. Let me call it Dublin because I've been there on the LUC conference last year, where I also met Rob. And now I can just drop some media here. It starts uploading. And maybe most of you recognizes the images as soon as they are uploaded, which takes longer than I expected here. Maybe because I'm in the Zoom meeting. But if you create tours here, they are available via a web link. And while it uploads in the background, I could also try to bridge the time and show you how such a virtual excursion might look afterwards. So we can go here and like I mentioned, it also supports videos. So if I go here, this was the LUC conference in Kyoto, Japan. So we can put video in there as well. But I hope my upload finished. Yes, it did. So I can just show you how to create a virtual excursion here, a virtual field trip. I can load the first scene. And there it is. You see my beautiful family, and I could create a move hotspot. Just click it and say the next linked scene is here, the central place of St. Stephen's Green, and go here and create an image hotspot and say, let's point it to the playground, which I know is somewhere there in the background, and say, here, take the picture of the playground. So now I can load the tour, and if I'm on a tablet, I can click the icon in the upper left corner and have the possibility to use the integrated sensors of my iPad to have a somehow immersive experience. And now you see I can walk around here, can take a look, can even click the integrated picture. So I have a lot of possibilities on enrich these panoramic images with more information than I have just in my panoramic image. And we said we want to go a step further. We don't want just to empower teachers to create those virtual field trips. But we come from the teacher training center. We have education in mind. So we think about active learning, inquiry-based learning. And why not make it a student's project, which the teacher can lead and create a tour where just the images are dropped in, and now the students have those pictures from the last class trip to Rome and have to annotate it with historical information about the Colosseum or whatever. So it could be used, yeah, for example, for the younger students which have not yet been to Rome and can get a better feeling for the size and the the feeling to really be there. Big benefit of that is that we have a somehow gradable product in the end. We can have little groups working together, and it's a good and alternative approach to assignment. So if you have project week with your students, you could just do that. And this reusability might even increase the motivation of the students even further to interact with the content and create something about that. The features for that are already integrated. We have a user management which allows sharing on different levels. So teachers can invite groups of students which are associated to their account. So students don't even have to provide personal information, not even an email address. And the user management on different levels means I can invite one group to actually edit one tour, while another group has the rights to view it. What do I mean with collaborative editing? Everything happens in real time. We are web-based, we have everything connected to each other, and if 5 students are working on one tour, they can do the share of work like they want, and everything they do, like placing hotspots or images or creating text in there, is available to their fellow students in real time. Users can chat, users can annotate materials or tours or scenes or whatever, so the others see it within the editor. But since we are researchers, we are coming from university, we also have deeper questions. We want to have learning analytics insights, so we integrated a lot of data collection. So our ideas behind that was that educators could supervise individual progress, that learners can get improved feedback, that designers and developers can recognize obstacles and problems, like maybe the hotspot I placed there is not visible or not visible enough, and most students overlook them. And researchers can hopefully, in the long term, gain a better understanding of immersive learning. We all did all that in standard conformant data collection according to the Experience API specification, which means we can also join it with learning analytics data, for example, from a Moodle platform and get a better understanding on a whole level on the learning process. So our possibilities for future analytics include adhering to the fair and open data principles, which means we want to be interoperable, though you don't have to use any proprietary tools or special tools developed by us. XAPI is an open standard by the IEEE, and you can use any tools intended for XAPI to get a look into this open data in the end. Still, there's an opt-out at every login. We have to adhere to the GDPR, so everyone can say in our big public instance, I want my data anonymized in this session. While if you deploy it in schools, you have a more fine-grained configuration on instance level. So you could either say, I want to only collect locally and anonymized, or I don't want to collect data at all. All that is possible. How does a learning analytics look like? This is what I presented at the last conference. The first insights, we have a side-by-side dashboard comparison. So you could here compare how do users interact with the tour on PC, laptop, or tablet, while on the right side we see virtual reality, so immersive learning. We did a lot since then, and we have new dashboards, which helps us to understand the navigation between scenes, the dwell time per page, the engagement with hotspots, and what I'm especially proud of is the saliency engagement correlation. So saliency maps, some of you might not know what that is, helps us understand where users look at in VR, for example. or within our environments. And brighter spots are where the users look more, while the darker spots are where the users do not look. And I can use that to see if users actually engage with my hotspots, which are placed here, or if they don't. Yeah, I also brought along some examples of real-world use cases which have been implemented with 19 Squared, which is the name of our tool, by the way. We have the project for Ort, literally on site, which was a cooperation with the local monastery, who said we have our churches and they're usually open, but there are always some doors which are closed, and we want to open those doors to the public without any risks or whatever. So they invited some kids from their community to come to the church with one of us with a 360-degree camera and help us create a virtual trip through the church behind the scenes. Another thing, an elementary school teacher from the area said, I want to go with my kids to the traffic practice area to learn how to read the traffic signs with their bicycles, but they are always a little overwhelmed when we get there. So I want to have the opportunity to get a feeling for this and the area and how to look around there before we actually go there. So we created a small tour of the traffic practice area here in Aachen. Another thing, we have a great cross-border nature reserve here, the Hohes Fenn Outre-Vents, which is a moor landscape. And it's actually pretty interesting. And it's pretty interesting from a biological and geographical point of view at each season of the year. But it's just not feasible to take a school class in every season there and compare the differences. But it's easily possible to take a 360-degree camera there in different seasons and try to give them a feeling for the different seasons in this environment. Another thing, a girlfriend of colleague of mine works for an engineering company which builds big recycling machines, and they have this technicum in Slovenia, and all their trainees have to go there at some point, and most don't get disorientated at some point if they go there. So they created it in 19 Squared so they can visit the engineering test center before actually going there. And the last project I want to present here is a food forest, which is just across the border in the Netherlands, which is a sustainable agriculture project where they try to build a forest which produces food in the long term. And bachelor students from the biology department used 19 Squared and one of our cameras to do an actual virtual field trip there, and also integrated some videos. So Rob, he's also called Rob, who explains how a food forest work and will work in the future. Yeah, just some more insights into our tool. So far, I presented you everything you need for a virtual field trip. Embedding of traditional content, multimedia content is possible, text, audio, image, video. It is possible to move from scene to scene through a landscape or whatever, linear or non-linear. And what we just recently added is more interactive elements like quizzes, matching riddles, or fill in the gap, drag and drop style, and conditional hotspots and transitions. So our idea is to create all foundations for digital escape games. So we have, for example, this dependencies editor where you can say, okay, you have to ring the doorbell before you can actually enter the building in this tour. And I'm pretty sure you can imagine more use cases for this tool. Other current developments we have, I have a master's thesis cleaning up the project. The title is from research prototype to successful open source project, which includes testing, hardening, and so on. And of course, AI. You can't get any project funding at the moment if you don't write AI on it. So we also experimented around with integrating AI here. And I will show you the two different approaches we took here. The first is assisted authoring. So you upload the panoramic image and it will be analyzed, and it will look for hotspots. It will guide you through a quick interview. How old are your students? What is your subject? What do you want to teach there? and it creates quiz hotspots, place them all automatically at interesting spots in your panoramic images. We also integrated document search, so you don't have to rely on the web search alone, and it's completely opt-in. So if you don't have sufficient hardware or access to OpenAI API, you can easily deploy 19 Squared without any of those features. What we are currently looking in, last month, a Chinese research group presented the first really reliable model for generating images, panoramic images in 360 degree in open source. And we try to integrate this in our pipeline. I have a master's student who started last week and already implemented a prototype, which actually works, and I'm pretty impressed. We'll do the generation within our interface. We'll do in-painting, out-painting. So you could, for example, take the horse fan image and say, okay, place a wolf in there and do something about extinct animals in our region, which would be quite an improvement. But we'll have to look if it's technology feasible at the moment, or we have to wait until big GPUs are more affordable now. So what I presented to you is an open source project, not that we did not build because we are the big RWTH Aachen University and want to have a prestige project. No, we built it because we feel a need for it. There is a gap we want to address here, and we invite everyone to contribute to this open source project. It doesn't have to stay a project of our university. We are actively looking for collaborators because we think one institution alone can't make a successful open source project in the long term. So if you're interested, feel free to contact me afterwards. We have a public instance which is somehow limited in its features because we don't have the technical infrastructure. But you can try it out there, 19squared.de. We have a demo video which we produced for the LAC last year. So you can look at the demo video. It's also in English, and we have an open source code repository with quite a lot of documentation in the integrated wiki where you can look into. And then just 3 minutes over my time, and I conclude my presentation here. Thank you for listening.